Hello and welcome. This week we are going to be talking about air quality index and criteria pollutants. So we are going to be learning about the 6 criteria pollutants. We will be calculating the air quality index and understand its significance. I will also describe the effects and sources of criteria pollutants in detail. So a brief background on the Clean Air Act. Clean Air Act was enacted in 1963 and was amended several times. This was the first federal act or first federal law in the United States that controlled air quality. Previously, before that, air quality was a state subject and it was controlled and managed by the states. But with Clean Air Act and then the formation of EPA in 1970, Clean Air Act directed the EPA to set air quality standards without consideration of costs. So that led to classification of two types of standards: primary standards and secondary standards. So primary standards are one that protect public health, including protecting the health of sensitive populations such as children, elderly, asthmatic, and then the secondary standards, which protect environment and public welfare, for example, decreased visibility, and damage to buildings, crops, animals, and so forth. So, and also there's another primary and secondary which should pay attention to: pollutants. So pollutants can be primary if they're directly released into the air, and they can be secondary if they are not directly released, but they react and form in the air. For example, ozone. It's a classical secondary pollutant, and carbon monoxide is an example of a primary pollutant. National Ambient Air Quality Standards. So the Clean Air Act requires the EPA to set NAAQS, or the National Ambient Air Quality Standards, for 6 principal pollutants, which are also known as the criteria air pollutants, which can be harmful to public health and the environment. And these 6 criteria pollutants are ozone, particulate matter, nitrogen dioxide, sulfur dioxide, carbon monoxide, and lead. And the areas or regions which meet these standards for these 6 criteria pollutants are called attainment areas, and the ones that do not meet these standards are called the non-attainment areas. So you can go to the EPA website. I've given the link here to look at the current level or current values of the NAAQS standards, and you can see these are, for example, carbon monoxide. 8-hour average limit is 9 ppm, and 1-hour average is 35 ppm. This is not to be exceeded more than once per year. If it does, that area falls under non-attainment, and so forth. You can see particulate matter is further broken into PM 2.5, PM 10, and they have different standards. PM 2.5 has a primary standard of 9 microgram per meter cubed, a secondary standard of 15 microgram per meter cubed, and a 24-hour average of 35 microgram per meter cubed. So anyway, these standards can be viewed at the EPA website, and you notice there are different units. These have ppm, ppb, microgram per meter cubed, and in our previous lecture we discussed some of these units, so we have a better idea of what these units mean. Here you can see a map of the non-attainment counties in the United States, and a lot of them you can see on the east and the west coast. Okay, and here is a non-attainment area boundary for the Fairbanks North Star Borough. Some of you might know that Fairbanks North Star Borough has been declared non-attainment for PM 2.5 since 2009, and it's trying to make its way back to attainment, but not yet there. So this is the borough map showing the non-attainment boundary. Okay, so air quality index. What's air quality index? We just looked at the standards, the NAAQS standards. They have all these different units in microgram per meter cube, ppb, ppm, which can be a bit challenging to, to understand for a common man, for a layman. That kind of those kind of units and concentrations could be hard to understand. So air quality index comes to our rescue. It's a valuable tool for assessing and communicating the quality of air in a specific area. And why do we need AQI? Because, as I said, it translates complex air pollution data into simple and standardized unitless scale that helps people understand the air quality in their region. So, what's the utility of AQI? It informs the public about the air pollution levels and what might be the associated health risks, simplifies the data for easy understanding, and could encourage people to adopt more eco-friendly behaviors. It provides guidance for vulnerable groups. So, for example, children and the elderly, should you go for a walk or not? Can the kids play outside in the lunch break? And they can just look at what the AQI is and make that decision. So, and then also it can aid in crisis management. It can also help in policy and planning support, because you can look at the AQI trends and see if the trends are not looking good. That could help decide if the pollution control agencies need to enforce certain rules. For example, in Fairbanks, we have certain days in the wintertime where you can't burn wood. So there's burn bans. So burn bans, they are based on the expected AQI. And then overall, AQI builds awareness, and laymen and more common population can also get an understanding of the air pollution levels, and which could promote demand for cleaner air and better policies. So the scale for AQI is anything less than 100. So usually 100 is what the standard is. So as long as you are below the standard, so it's basically scaled 0 to 100 is the 0 to the standard. So anywhere between the 0 to the standard concentration, or the highest allowable concentration, the AQI is 100 and below, which is considered good or fair air quality. An AQI of 100 means that we are at the national standard, and anything above that would be harmful for human health. And 500, for example, would be significant and imminent harm. Here is the current, the color-coded chart for AQI, and it's for ozone and particle pollution. But you can see the color. If you have values between 0 to 50, that means you're up to half the standard concentration. Then it's a green color and considered good. If it's 51 to 100, it's yellow. And then there is, as AQI increases from 100 to 200, it becomes unhealthy, and then very unhealthy, and 300 and above is considered hazardous. And there are like description of what you could or could not do under different AQI levels. And how do you calculate AQI? Typically, you would consider all the five out of the 6 criteria pollutants except lead, and you take the ambient concentration and convert it to AQI. So basically, you would interpolate it mathematically, or sometimes even extrapolate it mathematically to the range of values given, and we'll take a look at that in a moment. And then, so you calculate the AQI based on interpolation for all the 5 criteria pollutants, and then the maximum of those 5 is what would be the AQI. There's a nice calculator on AirNow website where you can convert AQI to concentration and vice versa. That's concentration to AQI. There's also this website that can predict or can provide forecasts for AQI in any part of the US. It's an EPA partner website, airnow.gov, and yeah, you can just put in the zip code and it will give you the AQI. I've also put in a link for an Alaska specific AQI website. Okay, how do you calculate AQI? You would need what's what I call the breakpoints. So this is a table which was revised in 2024. You can also find out. I've provided this as a handout on Canvas, so you can access this. But you can see if your let's consider PM2.5 at 35.4 microgram per meter cubed, your AQI would be 100, and at 9.1 it would be 51. So you could scale linearly between 51 to 100. So if you are 75, that would be midway between 9.1 and 35.4, and so on and so forth. So we will do an example based on these breakpoints to calculate the air quality index for a given scenario. So here's the question. So let's try to solve it. Okay, let's consider this example to calculate the air quality index. So just let's review how do we do the AQI calculation. So first step is we are going to consider 5 criteria pollutants, except lead. So we have 1, 2, 3, 4, and 5. We'll consider all these 5 criteria pollutants, counting PM2.5 and PM10 as a single, but we would have to do a separate calculation for the two of them because they have separate standard values. And then we convert the ambient concentration. So these are ambient concentrations that are given to us here. We convert these ambient concentrations into the AQI values, convert ambient concentrations to AQI values by interpolating the numbers in this table. And then after we have done that, we will calculate the overall AQI. We will calculate that as the maximum of the 5 values. Okay, so let's do one by one. So for carbon monoxide, let's see. So AQI for carbon monoxide. Okay, the concentration is the concentration given here is 0.9 ppm. So let me say if I call the AQI of carbon monoxide as X. So okay, now I will look at this table here. So this table, I'm going to use these values right here. So between 0 to 4.4, it's scaled to 0 to 50. So what I'm going to do is I'm going to say 0.9. Pay careful attention here what I'm doing. I'm basically just interpolating divided by 0.9 minus 0, so because 0.9 is given to us, divided by 4.4 minus 0 would be equal to x minus 0 divided by 50 minus 0. So we are just scaling these values to the concentration ranges given here. And if we solve this, we get x as equal to 50 times 0.9 and divided by 4.4, which is equal to 10.2. Okay, so that's one. Let's do the next one now. So the next one is for ozone. The concentration is 0.064 ppm. So AQI for ozone, and the concentration given is 0.064 ppm. And again, I will call or assume that AQI of ozone, if I call this as X, and now we will be looking at ozone table here, and this ozone is 0.064 ppm, so we are right here and here. So we'll take these numbers, and this time it will be slightly different because we are in the second row. So 0.064 minus 0.055 divided by 0.07 minus 0.055 would be x minus 51 divided by 100 minus 51. So that means if I solve this, I get 0.009 divided by 0.015 and multiply by 49 equal to x minus 51. So you solve this, we get x equal to 80.4. Okay, so you get the idea by now, I guess. So next, let's do for AQI for NO2, and the concentration of NO2 is given as 35 ppb. So again, I will assume if AQI NO2 is equal to X, and then again I will go back to this table of and look at NO2. So 35 ppb is again the first row. So we will write 35 minus 0 divided by 53 minus 0, x minus 0 divided by 50 minus 0. You solve this and get x equal to 33. And same way, let's do the AQI for SO2, and for SO2 we are given a concentration of 6 ppb, and I'll assume AQI of SO2 is X. This makes my life simpler. I don't have to write this AQI SO2 again and again. And then if I look at the chart again for SO2, it's again we're in the first row, so we would have 6 minus 0 divided by 35 minus 0 equal to x over 50, and this would give as x equal to 8.6. X equal to 8.6. Okay, and now we have left PM 2.5 and PM 10. So let's do those two as well. Oops, trying to save some space here. So AQI of PM 2.5 The value given is PM2.5 is 18 0.7 microgram per meter cubed. This one is now, if you look at this table, this is in the second row here. So we would have 18.7 minus 9.1 divided by 35.4 minus 9.1 would be equal to x minus 51 divided by 100 minus 51. And if we solve this, you would get an x of 69. And finally, for PM10, the concentration given is 62 microgram per meter cubed. And so this time we are again in the second level here, or second row, I mean to say. So 62 minus 55 divided by 154 minus 55, so we are using these numbers here, would be equal to x minus 51 divided by 100 minus 51, and we solve this, we get x equal to 54.5. Okay, so we calculated all these values, and now our next step would be to just calculate the overall AQI. So the overall AQI would be equal to the maximum of all these different values, right? So maximum of, we had 10.2, we had 80.4, 10.2, 80.4, then we had 33, 8.6, and then we had 69 and 54.5. So of all of these values, the highest value is 80.4, and that gets to be the air quality index.